Okay, in this video we will find the stability of a system using Nyquist plot. Let us consider the open loop transfer function of a system with unity feedback with HFS as equal to 1. So let us consider the open loop transfer function as 100 by s plus 1 into s plus 10. So let us try to represent the open loop poles in the S plane. Suppose if I write this as the S plane, now I have a pole at -1, so this is the pole at -10. Let us write the Nyquist contour, which is covering the entire right hand side of the S plane. So this is S plane now. So let me write the Nyquist contour. This is Nyquist contour. This is how it is going. So it is starting with 0, and of course it is imaginary, it is 0, and it is to j infinity. It will come back to minus j infinity, and it will again go back to 0. So now we write this as segment 1, this as segment 2, this as segment 3. Let us, of course, since we are covering the entire right hand side, okay, this is having r e power j theta. So now let us try to write the values of s in segment 1, where s is equal to j omega, where omega is ranging from 0 to infinity. In the second segment, s is replaced by r e power j theta, where r is tending to infinity, whereas theta is varying from 90 degree. Of course, let me just write it as it is from 90 degree through 0 degree, and it will go up to minus 90 degree. This is what is 90 degree, 0 and minus 90 degree. And the third segment is s is equal to j omega. It's minus j omega. Now omega is ranging from minus infinity to 0. It's actually from 0 to infinity. If you can see here, this is 0 to infinity, and then from infinity at an angle plus 90, infinity at an angle 0 degree, infinity at an angle minus 90 degree, and it is minus infinity to 0. So this is a Nyquist contour which is being represented in S plane. Now to know the stability of the system, we need to know how many closed loop poles are there to the right hand side of the S plane. Suppose if we have even one closed loop pole to the right hand side of the S plane, we say it as system is unstable. So now to do that, so now first and foremost thing in Nyquist plot is, first we should identify the number of open loop poles that are enclosed by the contour. Since all the poles what are there are not enclosed by this contour, so this p is equal to 0. So this p is equal to 0 means number of, so let me write it as, it is nothing but number of open loop poles enclosed by the Nyquist contour in S plane. This is the definition of P. So since none of them are inside this, so it is P is equal to 0. Next we need to find the value of M. That is, now this n value is nothing but I should map each and every point of this Nyquist contour in S plane to GH plane. So to do that, so let us take the expression GFS into HFS is equal to 100 by S plus 1 into S plus 10. To map the first segment, replace S by j omega, so that this becomes 100 divided by, okay, now it is, okay, let me write it as, this is now 100 divided by j omega plus 1, and it is j omega plus 10. So let us write the magnitude of that using this complex term. It is 1 plus omega square divided by 10 square plus omega square. This is the magnitude. whereas the phase term is minus tan inverse of omega minus tan inverse of omega by 10. So these are the magnitude and phase of this particular segment 1. So let us try to know what is the values of magnitude and phase for different values of omega. To start with, let us take only the extreme values, which is nothing but 0 and infinity. If you substitute omega as 0, what you end up with is, suppose if omega is 0 here, can you see it is 100 by 10, which is equal to 10. The phase is actually 0 degree. Suppose if you substitute omega as 0, tan inverse of 0 is 0, tan inverse of 0 by anything is again 0, it is 0 degree. So at omega is equal to infinity, when you put these two as infinity, the denominator is infinite, so that magnitude becomes 0. The phase angle will be minus 90 and minus 90, this will become minus 180 degree. So this is minus 180 degree. So you have minus 180 degree and 0 magnitude. So this is how this contour, which is there in what S-plane, will be replaced by, suppose if I write the same thing in GH plane. So this is now the GH plane. So this is the magnitude, which is nothing but this, here this is 10 magnitude, phase angle is 0, which is exactly this. And you can see the magnitudes keep reducing from 10 to 0 and phase is increasing from 0 to minus 180 degrees. So it actually goes like this. So this is the plot. This is segment 1 mapping. Okay, this segment is now mapped to this now. Now let us map the segment 2. So for mapping segment 2, we have S is equal to R e power j theta. So in this expression, wherever S is there, replace it by R e power j theta. Then this becomes 100 divided by R e power j theta plus 1, and it is again R e power j theta plus 10. So since R is tending to infinity, so you can treat this as zeros compared to infinity. So this will become 100 divided by R square e power j 2 theta. So if you apply the limit of R tending to infinity, then this becomes 0 tan angle minus 2 theta. We know that theta is varying from 90 degree, 0 degree and minus 90 degree. You substitute that, it will become 0, minus 180 degree, 0, plus 180 degree. So all these points have a magnitude of 0 here. So what is the mapping of this entire segment onto GH plane? It is simply a dot at the origin. So this is a dot at the origin. So what we are doing is we are mapping each and every point of Nyquist contour in S plane to GH plane to find the value of n, where n is nothing but number of encirclement of minus 1 plus j0 point in GH plane. So that's what is n. So now we have mapped this one, which is exactly this, and we are trying to map this semicircle, which is a dot at the center, and we know that the third segment is exactly the mirror image of the first segment. So even without writing, you can still write it as this as the mapping of the third segment. Now you can see minus 1 plus j0 is here. Minus 1 plus j0 is this. Now what is the value of n now? So n is nothing but number of encirclement. This is encirclement of minus 1 plus j0 by the Nyquist contour in GH plane. This is very important. It's the number of encirclement of -1 plus g0 by the Nyquist contour in GH plane. If it is in clockwise direction, then n is positive if the encirclement is clockwise. If the encirclement is anti-clockwise, then it is the value of n is negative. If it is not encircling, as in this case, so n is equal to 0. So n can be 0, it can be some positive value, it can be negative value. So these are the possible values of n. So in this case, since it is not encircling, n is 0. So now we need to find the value of z. So where z is nothing but number of closed loop pores lying onto the right hand side of the S-plane. So now that is given by n plus p. We know the value of p as 0 from the open loop transformation. We saw that n is also 0 from the Nyquist plot, so that z is equal to 0. So that I can say system is stable. Now the question is, what is gain margin and phase margin? These are the margins I need to know. To know the gain margin, phase margin, we know that n has to become 1, or minimum, of course. If z becomes 1 or more than 1, then system can be unstable. So now, since it is not at all encircling, z is 0. Now we are trying to find out, so this is from here to here. So now if you can actually see, if you are increasing the value of the gain from 100 to 1000, 1000 to whatever, so does this, will it anytime cross this -1 plus g0? It will never cross. So since omega pc is equal to infinity, gain margin is infinite, meaning you can never make the system unstable by increasing the gain of the system. So this is gain margin is infinity. Then what is phase margin now? So we know that phase margin is given by 180 degree plus of phase at omega gc. So what you can do is, you can first find out what is omega gc. To find out omega gc, so what I have to do is, I need to find out for what value of omega g's, for what value of omega this magnitude is 1, and let me find out what is the phase at that point. So for that, what I'll do is, I'll equate this 100 by this quantity to 1. So that is, at omega equal to omega gc, does this magnitude is equal to 1, which is nothing but 100 by 1 plus omega gc whole square into 1 plus omega gc. This is actually 10 square. This one is 10 square omega gc square. So now I will use the calculator and then make it. So instead of making this 1 equal to, I can do it as 100 equals, open the parenthesis, 1 plus omega gc whole square under root of 10 square plus of omega gc whole square. So now that's what I'm doing. It is 100 alpha equals, open the parenthesis, under root of 1 plus alpha a square, close the parenthesis, multiplied by, open the parenthesis. Just a minute, I'll just open the parenthesis here also. 1 plus alpha a square, close the parenthesis, multiplied by, open square root under root 10 square plus alpha a square, close, shift cal. Let me see what is omega. This will give me omega gc. So now from this, omega gc is 7.81 radian per second is omega gc. So let me substitute this value of omega GC onto the phase equation to find. So phase equation is minus tan inverse of omega minus tan inverse of 0.1 omega. So to this, so I want to find phi at omega GC, so which is nothing but, so now it is minus, okay, minus tan inverse of alpha A minus tan inverse of 0.1 alpha A. I will calculate A is equal to this, then you can see it is minus 120.7 degrees. So now what is phase margin? Phase margin is given by 180 degree plus of phase at omega GC, which is nothing but 180 plus of minus 120.7 degrees. So this is also degrees, that is plus 180. So it is, you can see 59.28 degrees. So this is phase margin. So now we know that gain margin is infinity, phase margin is this. So system is absolutely stable. Of course it is stable. It's not only stable, it is absolutely stable, because by increasing the gain from 100 to whatever, you can never make the system unstable. Hope you have understood this. We'll solve one more problem in the next video.